My name is Carlene Patterson, and I am one of the hosts of Alliance in the Public Eye. And I'm also here with Justin Swarbrick, the other host of this educational podcast and webinar. And it's a series that we have started to focus on the risk management challenges being faced by public entity risk managers. But after we recorded a couple of these podcasts, and the first one on weather and climate change, we realized it was an issue that impacted all industries and not just the public entity space. And we also thought it was something that deserved some additional attention. The data and the trends that we see in weather patterns are explained much better using charts and graphs. After all, a picture is worth 1,000 words. So we asked our guest presenter, Andy Siffert, to come back here and present on weather changes in a webinar format. Before I introduce Andy, just a reminder that please submit any of your questions in the Q&A chat box, and we will have the presentation for about 45 minutes and then save about 15 minutes at the end to answer the questions. So please, send the questions, and Justin and I will monitor them and have them ready at the end. So, a quick introduction for our guest presenter, Andy Siffert. He is a vice president and senior meteorologist at BMS Re and is on the U.S. Catastrophe Analytics team. BMS is an independent specialty firm providing comprehensive solutions and advisory services to the insurance, reinsurance, wholesale, and capital markets industries. He works closely with clients to help them manage their weather-related risks. He has over 18 years of industry experience, and that includes a master's degree in meteorology from the University of Utah. And he was also a member of the 2002 Olympic Weather Support Team. Welcome, Andy, to our webinar.
Well, thanks a lot for having me. This is one of my very favorite talks to give, and I love educating everybody about weather. I always like to say, everybody's impacted by weather, and there's no better way to share this than actually kind of showing data and versus just kind of talking about it on a podcast. So thanks again for having me. I guess as we get started here today, I just a little bit different topic. You'll see why this title slide ties in actually one of my very first slides here. But basically talking about weather trends today, tornadoes, hurricanes, floods, and wildfires. Oh my, right? And but first, let me just tell you a little bit about BMS. BMS, is a dynamic global broker that provides specialists in insurance, reinsurance, capital advisory services, and we're working with Alliant to really, bring a specialist like myself into helping educate, Alliant's customers and potential customers about weather trends. And that's kind of our partnership and one of the things that we're just partnering on. But really, as we talk about the weather trends today and we go through our agenda, I really want to first set our notion of extreme weather risk perception. I think this is really important, and you'll understand why as we go through the presentation. And I also think it's very important to discuss weather scales, the variability and volatility around weather and our climate. And then we're objectively going to go through a lot of data. We're going to go through a lot of data to review the weather and climate and the data that's really relevant to the insurance industry. So with that being said, let's start off, with a little poll. I know I can't visually see you, but this kind of made me raise your hand or think physically, or think about, is the weather getting worse? Are things getting worse? Are severe storms getting worse in the last 5 to 10 years? Are wildfires getting worse in the last 5 to 10 years? What about those heavy rain or flood events? Are we seeing more of those? And then lastly, like named storms such as like a hurricane, are they getting worse in the last 5 years? Because I think some of the data we're gonna answer these questions. I'm gonna go through all the data to answer these questions, and I think it's important to first set your mental mind frame of what do you think actually is happening, and why is that? Because I think it all started basically in 1939, right? There's this blockbuster movie that came out, and it's funny because there's this cowardly line in there that says, "Unusual weather we're having, ain't it?" Right? That's the exact quote. And he's sitting there in a poppy field as snow is falling. And I think this is our very first instance where a blockbuster movie is promoting the idea of this average weather that can manifest into extreme weather, right? The idea of this garden variety tornado transporting this little girl and their dog into this alternative universe. And from there, Hollywood goes on to produce many more of these types of films, and weather is ultimate driver of ratings in a lot of films and ultimately our nightly newscast, right? So let me just play a little video clip here of what I'm talking about. Weather, extreme 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 weather, the extreme weather, extreme weather, extreme weather, extreme weather. So now, if you didn't hear that, they were actually saying extreme weather over and over again, and our media is ultimately, uh, infatuated, or we're actually infatuated that, and that's why the media kind of focuses in on it, and it's basically a highlight of our morning or afternoon or nightly news. In fact, even this morning, I was watching CBS and was at the gym, and sure enough, one of the top news stories was the snowfall and the extreme snowfall that was occurring in the front range of the Rockies, right? But so it's no what this is doing is this is fueling armchair meteorologists. There's self-proclaimed armchair meteorologists are at all-time high. It's never easier to get weather information from Twitter or a blog or some app. In fact, there's actually 4 television stations that are solely devoted to weather. And because of this, it's never easier to get weather information. And because we so closely watch the weather and some of us are so infatuated by it, sometimes it's very easily to become brainwashed with the idea that normal weather is somehow extreme, right? And that's kind of one of the things we're going to talk about, because ultimately I kind of always say extreme weather is somewhat generational. Our weather memory is generational. Let's take the example of these pretty cool dual tornadoes that occurred in Midway, Indiana, from one of the biggest tornado outbreaks in history, which was April 11th, 1965. Right? Two tornadoes side by side. That's something that, is pretty rare. But, recently, we had a very similar instance of that. How about we remember the Stockton tornadoes that occurred in Nebraska in 2014, right? Again, dual tornadoes. But again, this is an extreme event that doesn't happen very often, but they do. And when they do, we're only going to really remember back to the most recent event, maybe in 2014. How about we take the idea of a hurricane hitting Miami area? Maybe we do remember back to 1992, the last major Category 5 hurricane to make U.S. landfall just south of Miami. But how many people were really alive and remember the 1926 major hurricane to hit Miami, right? Miami is a much different place than it is now. And do we really remember those last big weather events? I mean, some might say our memory of a Hurricane Andrew type event hitting, South Florida is actually, kind of going on the wayside, because we just haven't had a major hurricane like Andrew hit that area since 1992. And this brings me to the other point. The population is changing, right? Miami is not the same Miami it was in 1926. This also is also important when we talk about the weather data, right? So when we populated the United States, it was mostly on the East Coast. We started building some minor weather records of the occurrence of maybe extreme weather through time. As through time goes on, we start populating more and more the Central Plains, and now we start documenting extreme weather phenomenon because of that. But it was still pretty sparse. The observations were still not that great. But through time, our population was also expanding into these bigger and bigger concentrated areas. We were more and more focused on parts of the coastline of the United States, in an earthquake-prone California or the Pacific Northwest. And ultimately, a much more population is now focused in these major metropolitan areas, and much more population is focused around the U.S. coastline, right? But in terms of that, we actually do have really good weather records as a result of more and more population and more observations of weather, which we'll dive into in a few slides. But this is also leading to areas like this, Marco Island in Florida, right? Basically, uh, uh, urban or built environment, basically built on, marsh, sandbar. And this area is very lucky that it didn't get more devastated from Hurricane Irma in 2017, with the storm surge actually, the worst of the storm surge going just east of this area. Even though this area did get impacted by a Category 3 winds, it was quite fortunate. And what I call this is disaster by design. Should we really be developing and building in a built environment like this? And it's not just in the US. This is an example of uh, the Thailand floods in 2011, where I had the opportunity to go there working for a previous employer to understand the impacts of this event. And we have known factories, known groups of population that have willingly built on known floodplains, right? It's just that these areas don't flood that often, but when they do, they can be quite devastating. And this all gets back to the idea that, we're building in some of cases, we're building in areas that are more exposed to hazard or exposed to hazard. And the idea of, we call this the bullseye effect. In 1950, a urban area was quite small and you might have a tornado or a flood situation. But over time, that bullseye expands, the population growing. I mean, maybe in this urban environment you live in, you've actually seen cornfields being taken over by, housing developments. That's basically what we're talking about here, where the urban area is actually getting more and more dense, and the suburban area is actually growing out from that urban environment. And when you do get a tornado, now it's impacting more and more exposure and more uh, portion of that population than it might have historically. And this holds through basically any peril that we're kind of going to discuss here today. And so ultimately, when we talk about natural catastrophes are increasing, right? That's the question. We know that our population is increasing. There's an increase in values of our uh, insurable risk, with the insurance penetration increasing and a concentration of exposure increasing. But really, what we want to ask here today is our hazard changing, right? That's what we're going to really dive into. But before we do that, first I need to focus in a little bit about weather scales, variability, and the volatility around weather. And first, we need to define climate versus weather. Weather is this basically set of adiabatic conditions that protect or that affect a particular area in a particular point in time, such as rainfall or temperature or humidity. That's kind of weather. Climate is basically that period of weather that makes up that changes over much longer periods, like decades or hundreds of years. In meteorology, we like to define the climate as kind of a 30-year period. In fact, we're just moved into a new climate period within this new decade, right? So we're looking back at the last 30 years to define kind of what our normal climate is. So overall, weather is basically this pattern over a particular area of that given day, and the climate is how that weather changes over a longer period of time. And it's quite complex, right? It's not just about temperature. It's about and changing. It's about other remote forcing mechanisms. We have ideas of how sea surface temperatures can definitely impact our different types of risks, such as drought and tropical weather. For instance, El Nino, La Nina, here as I'm showing in the slide, if you warm and cool the ocean temperatures just by a degree or two of the largest body of water in the world, it's going to have an impact on our upper air, other sea surface temperatures and surface temperatures that is ultimately going to impact drought, tropical weather, rainfall, and severe weather patterns. I mean, these are known occurrences just because this large body of water is so can have such large influences. But it's not just Pacific Ocean temperatures, it's sea ice. There's solar radiation, right? Our sun is actually amazingly constant, but it does fluctuate over an 11-year period. That can also change some of these other factors. So one of the other things I like to point out is the volatility around weather and climate. And when we think about weather, the best way I like to into volatility is I like to show temperature because we can now kind of relate to it. Now, this is what we're showing here is a bunch of numbers on a map, but what are they? It's the lowest temperature observed in the state and the highest temperature ever observed in the state. Now, granted, some states are very large, but we're all calling in from different parts of the United States. So it's a great way to kind of just show how volatile the weather potentially can be. For example, if you're in California, there's a great diversity between the high peaks in the north and south of the state of the Sierras versus the Death Valley in the south, right? So you can get these very extreme temperatures, and that 179 degrees is the difference between that. In fact, I'm talking to you from Minnesota here today. 175 degrees is the difference between that minus 60 and 115, and I was around and remember vividly because actually they canceled school in 1996 because it was so cold when northern Minnesota got to minus 60 degrees. I know you're like, how do you live here? Well, it's because it can get to 115 in the summer for maybe that one day. But ultimately, it can be quite volatile. And that's the point that we need also a longer term period of record to understand that volatility. And Earth is old, right? And humans have really only been here on a fraction of how long Earth has been around. When you think about our observations of weather, it's even that much more smaller, right? Our earliest temperature records go back to 1659. We really don't even have a good picture of global temperature until 1850 with true good observations because and even there, the observations were really sparse in Africa or even in the Amazon or even in the Arctic or Antarctic, right? It wasn't until really recently that we have really good satellite-based observations of temperature of what around the world. Now, when you talk about perils that impact the insurance industry or particular pieces of property, it's really, we have even shorter records because again, extreme weather is by definition something that doesn't happen very often, right? You need a longer period of record to determine what's extreme just by definition. So our start of our hurricane record is 1900s, and our tornado data really starts in 1950s. So let's focus in on a little bit of the data now that we understand that. And let's first dive into the severe weather aspect. Let's first also look at what's going on with loss. Well, this is the U.S. insured loss data from U.S. severe weather. And you'll see from 2005, there's a steady increase of this loss with maybe 2011 being driven by, particular events like Joplin and the Tuscaloosa major tornadoes. And 2020 was a record loss year. And the loss year is shown by the large purple or dark blue bars with the index or the loss in billions of dollars over here to the left. The orange bars that are hollow are basically the number of events of $25 million or more. So how many of those events actually make up that total loss? And you'll see, again, steady, slow increase, but maybe not as big an increase. And the scale over here is to the right. Now, 2020, we have obviously a record level number of losses, but not the record number of events. But ultimately, the loss here was driven by that derecho in Iowa in the middle of the summer. So, but I'm a big proponent of don't look at loss to determine trends in weather, because we know there's so many external factors, as we pointed out in the many slides before this, that our population is changing, our exposure is changing over time, our increase in values. Your home is hopefully worth more now in 2020 than it was in 2005, right? There's a lot of external factors and socioeconomic factors that can drive different loss numbers. So I'm a big proponent of let's look at the weather data. So let's do that. We're going to look at a lot of charts here, and all of a sudden you're going to say, and they all kind of look the same, at least for severe weather, and you'll see that this is for wind damage reports. Now, this is data reported to the National Weather Service that starts in 1950, and you're going to notice that there's a huge uptick in wind damage reports. So, of course, in the long term, the trend here is for more wind reports. However, there's nuances within the data, as we talked about. Our ease of reporting data has gotten better through technologies. So I always like to point out kind of the internet age, that it started in basically the mid 1990s, is when we really had the ability to report weather much easier than basically kind of a landline type phone. And then in 2007, what happened, right? The iPhone, the smartphone era. So these are all important points that I want to point out in this longer term uptick of wind reports, hail reports, and tornado reports in the next few slides. But here we're looking at the severe weather aspects of, uh, and we see, I always kind of like to just focus in on that smartphone period. There's still a steady increase in wind reports over that period of time since kind of 2007 or at least the early 2000s. Um, there's been a little bit of up and down period. 2011 was an outlier year with a lot of severe weather, but over the last 3 years, there's been more wind reports being reported, and terms of damage to the weather service. But ultimately, there's a little bit of kind of variability year to year now that we have a little bit more steady record, but definitely an increase in the last 3 years. Now, hail is a huge driver of insured loss. What is going on with hail? Now, again, we have the definite increase with better observational techniques, but kind of in the smartphone era, what's happening, right? So if we take the data from 2000 or so and bring it forward, what's kind of occurring? Well, we had a peak with that a lot of severe weather in 2011, but there's definitely been a period of 3 or 4 years now where there's decreased hail observations of 1 inch or more. Now, I always like to point out 1 inch or hail or more because 1 inch of hail is when you get a lot of damage. Now, the 2020 data is not preliminary, but it's definitely historically low. When we look at the overall reports of severe weather, and we'll talk about or hail, I should say. When we talk about tornadoes, you'll notice a slightly different picture here. We're seeing that tornadoes, we have a much better historical record, maybe as a result of Wizard of Oz movie in 1939, making it so much more well known that this extreme phenomenon can occur. And obviously a tornado is an extreme, it's very rare when one occurs, so you're likely going to report it anyways. So we don't have like that observational bias that we might see in some of the other wind and hail reports. The tornado reports now, what we see is actually a very nice steady trend with year-to-year availability, but definitely an increase in more tornadoes over the last couple of years. Now, these are EF1 tornadoes or more, which goes through an EF1 through 5 scale. And we'll see that, again, 2011 was a very high year. But if you remember, some of those major tornado outbreaks of the 1968, like the Palm Sunday outbreak I talked about, it's right on up there with what we might have seen actually here in more recent times. So ultimately, yeah, some tornado increases, but a lot of year-to-year variability, and really not, we have good long-term historical records, so maybe not a much of a decipher of trends of what's going on with EF1 tornadoes. But if we look at EF3, 4, and 5 tornadoes, what's actually going on? Again, since it's a very extreme rare event, we actually probably have really good observations of these events, because if they scoured a cornfield and tore up the dirt, which an EF3 tornado would do, even though it didn't impact any homes, it likely still got reported by a farmer historically. So we have really good records historically of EF3 tornadoes, and we see a long-term trend of these EF3 tornadoes actually decreasing. And particularly over maybe the last decade or so, we have seen less of these EF3 tornadoes. But in fact, some scientists actually suggest that we're actually in a major tornado drought. When you look at EF4 and EF5 tornadoes, we're in a period with EF4 and 5 tornadoes where the period of days between these tornadoes is getting longer and longer. In fact, if we don't get an EF5 tornado this spring, and let's hope we don't, we're actually going to break the record between 1999 and 2007 of 2,922 days between observations of EF5 tornadoes. Now, you don't really hear much about that, but it's actually pretty significant. And we're seeing these stronger tornadoes actually decrease in occurrence. We don't have time to kind of discuss why that might be, or maybe we can talk about in the Q&A section, but ultimately this is a trend that is ultimately good for the insurance industry or property market. But when they still do occur, it can be quite devastating. So just in summary, in terms of short-term trends of the reports from like 2005 to current, where do we kind of see, that tornado report again, there's overall tornado reports haven't really changed too much with a little bit of year-to-year availability. Hail, there's a little bit of actually a decrease in hail reports um, over the last several couple of years. And then when we look at the overall wind reports, there's actually a slight increase in the number of wind reports over the last couple of years. So when it comes to severe weather, I think it ultimately comes down to a matter of luck, unfortunately, because we know from last year, tornado hitting Nashville, again, the outskirts of Nashville have grown tremendously over the last few years. So again, that's why that was such a devastating event. Even though it did hit parts of downtown, we know that hail is a costly driver still to the insurance industry. And we know, wind events like the big wind event that hit Iowa can still cause devastating damage to areas like Cedar Rapids. So severe weather really has no boundaries. And sometimes it is, just as I'm showing here in this image, a matter of luck of that, farm building being basically just spared, by a tornado, right? So let's move on forward now and talk a little bit about flood. Now, flood, again, let's focus in on the losses. Flood ultimately is driven, increasing insurance penetration is occurring, but a lot of it is still handled by the National Flood Insurance Program. When we look at flood losses over time since like 1995, we see that losses here are, driven by particular events. And now what happened in 2005, right? We had Hurricane Katrina, Rita and Wilma, major hurricanes. In 2012, what did we have? Sandy, which caused devastating flooding in New Jersey and New York. 2017, of course, we had Harvey, right? And what we have, and when we look at it, examine the National Flood Insurance claims data, we can see that these flooding occurrence is occurring not only along the U.S. coastline, but also along our major riverways, right? So ultimately, flood losses are increasing. Hurricanes are the major driver of that. But what's actually occurring with floods in terms of the overall trend? And for that, the best way to summarize that is through the most recent literature. Um, and it's basically breaking it down by different river basins where we have really good river gauge data. And when we see the red kind of triangle or upside down triangles here, that's like kind of pointing to decrease, basically significantly decreasing in the magnitude of floods. When we have blue triangles up, that's the significant increase in the magnitude of floods. And the river, basically the frequency of flooding is another way of looking at it. And we're seeing, it depends. It depends on the area of the country you're really focusing in on and the type of river basin and what's going on in that river basin that really drives the overall flood magnitude and frequency. So it is very regionally dependent. So just keep that in mind. But there's external, as I talked about with the severe weather, there's external things that can ultimately drive our weather observations of flood. For instance, let's take Iowa, very flat. If you've ever been there, there's not a lot of terrain. And when we ultimately get rain or snow melt in Iowa, it's going to flow down to the southeast. But what's interesting here is uh, it's being relatively flat and being some of the most profitable farmland in the country. Farmers have actually started drain tiling fields. And what the problem with this represents is it's going to increase the ultimately frequency and magnitude of flood events, right? If you're taking large portions of the Midwest and drain tiling these fields, which means basically taking water out of the fields that drain into a drain tile that goes into a ditch, that goes into a stream, that goes into a river, that goes, that's ultimately going to speed up that overall process of potentially a flood. So and the other aspect we need to understand is we're also trying to tame rivers, right? Human engineering is working to increase our extreme flooding, right? We're working on straightening and channelizing rivers and creating artificial levees to force water downstream and get water out of the way. And this is also increasing our tendency for frequency of flooding and extreme events. And then ultimately, we've seen a number of cases, right, where artificial levees have failed, creating a problem that's even worse. Now, the best way historically, though, to look at this true trend of what's actually occurring is just by looking at a hydrograph. And I've provided a link here down to the bottom where you can actually go through and pick your own favorite river and where you're from to pull this data out. But what we're looking at here is the idea of the orange plots are dry periods, the green and blues are wet periods. And obviously, in the summer in Iowa, this is in Cedar Rapids, Iowa, you have more rain and precipitation falling. But we notice through the time, now this is a very long historical record that basically starts in the 1900s, early 1900s, you'll see that as you move forward in time to the current period, 2020, we're seeing more and more green show up in the plot. Now, that's a function of definitely the drain tiling and different agricultural practices that are occurring in Iowa and other parts of the Midwest. It also has to occur with precipitation, which we're going to talk about. But we also need to understand that there's artificial aspects of this. Now, notice the historical crest here was 31.12 feet in 2008. That's about 10 feet higher than is observed in 2016. And we have a number of other historical crests. And this is just, I don't, for the interest of time, I only have time to focus on this one particular river system. But the point I'm trying to make here is 2008. We can look at this data and say, well, okay, we've seen a lot of increase in flood risk, but we also need to understand there's artificial things that you might not even understand that created that, right? For instance, this is actually where a train, went over, basically was on a bridge, and the bridge collapsed, and that ultimately created a dam, creating an even worse flooding situation. But you wouldn't know that by looking at the data, right? Unless I just told you about it or you researched it yourself. So there's artificial things within our data, whether it's severe storms or flooding, that ultimately can kind of that we need to understand. But ultimately, what we do know that there is more flooding events because of agricultural practices, and there's more flooding events because it's actually raining more. This is a trend analysis of the daily weather, basically the percent of land that in the United States that is actually observing greater than normal precipitation from single day rain events. So basically, think of it as the number of weather stations that are recording record day rainfall are increasing with time, particularly since the 1980s. And when you think about that, that's actually significant, right? Because now you have the agricultural practices on top of more rainfall events, creating more of a problem. So, and even though last year was a quite dry year overall, there's definitely just an increase in this overall number of extreme precipitation events. So when it rains, it pours. The next peril I want to dive into for a few slides is wildfire. Definitely an event that's impacting the insurance industry and commercial real estate industry, in particular in California. When you look at wildfires, this is why it's such a big concern, because it used to be considered a secondary peril to the insurance industry, but now is actually a primary peril. In fact, there's actually 12 modeling companies now that are devoted to trying to understand this risk and look at some of these large losses, right, from these particular near-term wildfire season, but historically we just didn't get that. So something's clearly going on. And ultimately, we are seeing more wildfires burn. We're actually seeing more the burn frequency increase. And I always like to kind of use basically the acres burned per fire as a metric here to understand that there's more and more wildfires, or basically acres burned per fire, that are occurring. So the wildfires that are occurring are actually burning more acres. But again, there's nuances in the data, such as the U.S. Forest Service enacted different burn policies here that could ultimately be driving some of this increase in fires. So ultimately, again, there's different tactics, there's different observational biases. Since 1982, different data sets were merged. So we need to consider all that when we talk about that longer term trend. But we do know that the data since at least 2000 has been fairly steady in terms of this metric, and we're seeing an increase in these larger fires. Now, when you combine that with how fires or how we as humans are changing the fire landscape and the fighter fighting tactics and how we're creating fires, that causes a problem because we know that ultimately that fires are largely human caused. Like you can go in 2017, 2016 were very large wildfire years, and they were either created by utilities or carelessness. 2020 fire season was quite unique in the sense that it was actually less carelessness, but mostly lightning fires. And that resulted in larger fires being burned in terms of the number of acres. But, fires are occurring outside of our fire season. I mean, we can just look at Fort McMurray or the Gatlin fires of 2016. Human caused fires, again, by, camping or whatever were the causes, but they were human caused, but they were burning outside of what you consider a normal fire season. So humans are actually causing more wildfires overall. Lightning is really changing. That hasn't changed too much, except 2020 was a very outlier year in terms of lightning fires. And when you take into account climate change is really only affecting a small portion of the fires that are occurring, but it's the human fires that are actually increasing the overall months and lengths of fires that are occurring. And we're seeing wildfires extend into the colder parts of the season as well. As I mentioned, Fort McMurray in May and in northern Canada and Gatlinburg in the end of November. So ultimately, humans are causing more fires. And the other aspect that humans are influencing is our WUI, what we call the wildland urban interface. And that's growing. So we see that the wildfire, a picture of an area just outside of San Diego in 1993, right? Very non-developed. The wildfire burned in this area. Now, if that fire were to occur from the foothills here today, look at how much more development in 2016 from the satellite imagery I grabbed would potentially impact, right? So again, we're exposing ourselves with starting more fires, but we're also having more and more exposure in this fires. And this is just from 1993, right? In terms of the development, as we talked about that bullseye getting bigger. Now, the last peril I want to focus in on is named storms. One of the costliest perils to the insurance industry and the overall you know uh, built environment that we have along the U.S. coastline. But this is the first peril I want to focus in globally, right? Because we have pretty good global data from 1970 due to satellites, and because they don't occur very often, we want to take a bigger picture. So what's going on globally since 1970s? Well, when we look at tropical storms, so what do we see globally? And this is basically a 12-month running sum. We see that basically there's not much of a trend with overall named storm activity. And this is again globally. Now, hurricanes, there might be a slight uptick, definitely since 2010, but over again, not a lot of big change globally in terms of the hurricanes. Now, where we see actually a big difference is when we take that hurricane plot over time. Again, not much change. But when we look at the overall major hurricanes, like the hurricanes that cause the most damage, we're seeing a slight uptick in the overall trend over a longer period of time. So that ultimately is concerning, right? Because our coastline is becoming more and more populated, and our storms are potentially becoming more stronger. So, but what we care about in terms of built environment is the overall landfalls, not really what occurs out in the open. So, what is that data telling us? Well, 2020 saw the most hurricanes strike land worldwide since 1970. So when we look at that data, what do we show? Again, maybe a slight increase in overall trend of kind of hurricane strength. The major hurricanes, we're seeing more and more globally major hurricanes make landfall. But again, we're not talking about a large number here. It's maybe going from 4 on average to 5 or something. So it's not that's globally what's going on. When you take into account the North Atlantic and Western Pacific, it's a little bit different because most of those two basins, the Atlantic and West Pacific, produce most of the landfalling hurricanes on in our database. Hurricanes are actually decreasing in the West Pacific and Atlantic, but overall major hurricanes really haven't trended much. So let's focus in now on the Atlantic basin. What do we see? Well, this is our overall named storm activity in terms of major hurricane activity. In the red, the orange, we have our minor hurricane activity, and then named storms in blue. This is the accumulation. So you definitely see an increase in trend since basically 1995 of more named storm, hurricane, and major hurricane activity. But we also had some periods of activity in the 1930s through 1950s and 60s. And again, kind of like all the other perils, there's observational bias, right? We didn't have satellites flying in space until the 1970s. Really, World War II boats were a great measurement of our hurricane activity, but we really didn't get that good activity until, but they still didn't, traverse into a major hurricane. So our observations of major hurricanes, even in World War II, were not great. It's really until 1970s we don't have really good quasi global records of what's going on. But again, it's landfalls that we care about. So what's going on with landfalls in the US? Well, this is categories 1 through 5 type hurricanes. We're seeing again that uptick, as I mentioned globally, same uptick of 1 through 5 landfalls. We're seeing more and more landfalls potentially make hurricane activity. Not a lot, maybe going from like 1.3 to almost 1.8. Not a big difference there overall, longer period of time, but there's somewhat steady increase in trend and definitely very active over the last couple of years, with last year being very active. Major hurricanes, not much of a trend here. In fact, very interestingly enough, we went through one of the longest periods historically without a major hurricane landfall after the 2005 season. So 2006 through 2017, we had no major landfalls. And you can just see how historically significant that is in terms of the period of record here. There's really no major trend in major landfall U.S. Perils or U.S. hurricane activity. So when you take that in terms of overall loss trend, and we take the data that we know from like maybe that 1928 Miami hurricane or 1925 Miami hurricane, 26 Miami hurricane, we can see that there are historically some pretty big loss periods, and we're have year to year variability there in terms of overall loss activity that is occurring, but nowhere near the period of 1930s and 1950s that we've had in terms of historical landfalls. These losses are now adjusted using a CAT model, saying in today's exposure, how big would these losses be, right? So we've had some pretty big loss years recently, but some of these bigger loss years historically would be pretty big in today's dollars as well, given the built exposure. So let's end with discussing our poll. So what did you answer, right? Severe storms. Well, it really depends. Definitely not tornadoes, I don't think are really increasing. Definitely not major tornadoes. Wind, I think, is increasing in terms of the peril. And hail, maybe. It's a little bit of a mix. But losses are definitely increasing due to exposure. And some of the data suggesting storms are shifting east into more exposure, right? More population lives on the East Coast versus the Central Plains. Heavy rainfall events. Well, it depends on regions. We gave the example of Iowa. There's, farming practices, but we do know heavy rainfall events are occurring more, and we know urban planning and is causing potentially poor urban planning is ultimately causing more problems as well, in particular areas like Houston. Lastly, we see wildfires are human caused largely, and there's more and more wildfires occurring, and we're increasing our exposure due to the WUI. So all this is ultimately increasing, ultimately with a little bit probably of drier climatological periods of increasing. When a human does start a fire, it's going to be worse. When we talk about named storms, there's more storms in the basin for sure, especially since 1995. but landfalls are really trending that much. Major hurricanes are potentially forming more and making landfall more. So with that, I just want to mention, I do tweet a little bit. I do my own blog through BMS on basically these types of topics and other thought leadership. And I do hope we do now have enough time for some questions. So thanks again.
Andy, thank you very much for that presentation. I think some of the conversations we had earlier are so much more impactful when you see the graphs and the data and the trends. Um, we do have a couple of questions. The first one
Great.
says, assuming you agree with data suggesting an increase in average global temperatures, are there any thoughts regarding how this increase in atmospheric and oceanic thermal energy will impact future weather issues?
Yeah, I mean there's definitely a lot of debate around this, and I try not to take one side or the other, right? I try to look truly at the science of everything, and the atmosphere is warming, and what the data is suggesting is when the atmosphere warms, what's happening is we are actually warming. The tropics are not going to warm as much because they're already hot, right? The poles are going to warm more than what they are. So what happens there is the difference between the warm and cold become less, and that's ultimately nature's way of balancing it out. So ultimately, what you would expect, potentially, like let's give the example of severe weather. Severe weather is going to be potentially less volatile, but when you do get more extreme um, temperature differences, you potentially could see more, especially over the built environment. You could see more extreme uh, uh, hail and wind events. Tornadoes are probably on the decrease because there's less shear in the upper parts of the atmosphere, and that's why we're seeing not a much of a trend in tornado activity. Hurricane activity is really interesting because a hurricane, as you can think about, is a way to take heat and moisture from the tropics and transport it in the mid latitudes. And in a warmer climate, you're not going to need to do that as much. So ultimately, you're going to need potentially less potentially less hurricanes are going to form because they ultimately need to transfer that heat and energy to the mid latitudes because there's won't be a mechanism to do that. That's what a kind of a hurricane is in its simplistic form. But when they do form, they could be more severe, and we're seeing that in the meteorological data.
Thank you. If there's any follow-up questions to that, please submit them. Dealing with public entities and a lot of when it comes to urban planning and that sort of thing, I guess I'm trying to talk about that human engineering. And if some of the engineering isn't quite what it should be in order to help avoid, or it's causing more severe flooding, what long term needs to be done in order to help impact the impact of flooding in especially in the Midwest and some of those areas.
Yeah, flooding is definitely. Particularly to municipalities. When you consider water treatment plants and everything or near waterways, it's definitely a problem. And I think we're seeing more and more extreme rainfall events. So when it rains, it pours, right? So we're seeing higher percentages of that. So I think what actually needs to happen is we need to take a step back and say, okay, are we channeling the river too much? Maybe we have to buy out some private land and channel the river around particular cities, or open up a levee system for allow the flood to actually flood. That's what naturally should be happening. And that's a tough decision, right? Because you don't want to take land from somebody necessarily. So there's obviously some moral issues to be worked out there, but ultimately, there's the problem's only potentially going to get worse, given some of the trending that we're seeing now. Of course, we can build our levee structures and flood defense mechanisms, higher and higher, but ultimately, when we do get a failure, it's going to be just that much more costly. So, it's tough in terms of how to prepare for these sorts of things. In terms of the modeling because there's so many moving parts, particularly with flood. Um, but and ultimately, just more and more development. I mean, it's hard to model how many more farmers are going to be drained time in a field. Like that's just going to be really hard. All that has to be fed into a hydrologic model that, there's some uncertainty there, so that becomes much more of a problem where building resiliency in the first place and solving the flood problem with maybe letting the river do what it more naturally can do, maybe upstream or downstream from the city, is maybe the better solution.
Got another question.
Yeah.
Are the
Right.
polar ice caps indeed melting, and will that meltwater not increase the risk of coastal flooding, especially during storm events?
Yes, I mean, the topic of sea level rise is an interesting one, right? Because it's hard to see that, right? We all go to our favorite vacation destination, and you may not see it, in a decadal period. Um, there's definitely evidence that the Arctic sea ice is decreasing year over year. There's mixed data suggesting our Antarctic sea ice is actually decreasing as much as they say, particularly in the last 30 years or so. But definitely like the Greenland ice sheet and things are melting in the northern hemisphere, which is just interesting in itself, right? So we have the northern hemisphere ice is melting and the ice sheets are becoming less, but maybe not so much in the southern hemisphere. But sea level rise is definitely an interesting topic because it's also about the sea level rising, but there's so much substance that is actually going on, right? So I mean, we take the Miami and the built environment, and you see like the king tides impacting Miami. Well, Miami, sure, the sea level rise is rising because of maybe a little bit of the global warming and glacier melt, but as water expands and warms, we're seeing warmer oceans. That's creating, it's got to move somewhere. We're also seeing the built environment take over natural areas where water should go, like the mangroves and things of the keys and things have been kind of built over. And we're seeing subsidence in Miami Beach, right? I mean, just look at the development. So there's actually sinking of, that sandbar that they basically built on because of all the weight of the building. But it's really area dependent in terms of sea level rise, but it's definitely a big problem. The nice thing is, and I like to point out with hurricane forecasting and storm surge, our forecasts are getting better. So maybe in the future, we will know where these hurricanes make landfall, and maybe you'll be able to put up a porta dam or something around a particular property to limit that sea level rise impact, right? Until something bigger can be done, and these are things that are many decades in the works to prevent sea level rise, but those are more short-term solutions that property managers can think about, is like porta dam type systems, particularly with forecasting being much better than what it used to be.
Hey Andy, thanks for the presentation. That was great. Um,
Thanks.
you started talking about the media and these armchair meteorologists. It seems like every spring we see the headline, expected record tornado year or record named storm, whatever it may be. How predictable is this weather?
You know what? And I think and I'm maybe biased as a meteorologist, but um, it's getting much better. I'll say that. And in fact, if you were to be an armchair meteorologist and you follow certain other meteorologists on Twitter or on different other forms of medium, I mean the severe weather outbreak that occurred in Texas just the last couple of days ago, I mean, that was very
Right.
well predicted about a week and a half in advance. I mean, we don't know exactly where that particular individual tornado is going to occur. We won't even know that until like an hour beforehand. But we know that a tornado outbreak will occur, just like there'll be a fairly significant severe weather outbreak with tornadoes occurring tomorrow night in the southeast, right? And that was actually predicted maybe about a week ago, or the snowfall event in the front range of the Rockies was very predictable. So I think a lot in even hurricane landfalls, we don't necessarily know exactly where the hurricane's going to make landfall. 2 or 3 days even before it makes landfall, but it's getting pretty accurate that we know a storm's going to form. We just don't know where it's going to go. So I think meteorology is and the forecasting is getting better, which I think is ultimately part of the longer term solution. If we can actually understand some of these extreme weather events and when they're forecasted to happen, it would just allow society to better prepare themselves and put resiliency efforts into, protecting infrastructure and, property when an extreme weather event occurs. The question is, the granularity of that can be difficult at times.
Right. Pre-season though, are you able to predict the activity that we're expected to see?
Yeah, great question. I mean, we're already kind of starting, BMS as a group is, we're supporting the reinsurance and insurance groups and the companies out there. And, we're looking at all these forecasted indices. So we're looking at the sea surface temperatures in the Pacific and the Atlantic and kind of our of what's going on in terms of the Gulf of Mexico sea surface temperatures and longer term upper scale atmospheric pressure patterns they're kind of pointing to another active hurricane season. So that's just saying that overall we're going to see more and more um, higher than normal number of named storms and hurricanes form.
Right.
We just don't really right now, sitting here in beginning middle of March, to understand where they're going to necessarily track this year.
Mm-hmm.
That will have a much actually, probably around June or July, we'll have a much idea. Say, okay, well, the Gulf looks to be another active year, or the East Coast, or the Southeast Florida, or something. So,
Right.
and I gotta stay tuned. The meteorology and isn't quite there yet.
How do the insurers and reinsurers, how do they use the data that you're giving them? So if you're looking at it saying, yeah, we think it's going to be a much more active named storm year or whatever it is, are they building that into their underwriting models to look at it and say, yes, when it comes to that type of cat exposure, we're going to be, in looking for rate increases on that? How do they use that data?
Yeah, that's a great question. I mean, on the insured side, I mean they're regulated, so they can't necessarily throw a rate increase due to a you know forecast of say more named storms, right? Because it's a little bit more regulated. Now on the reinsurer, there's more. It depends on the shop. There's more sophisticated reinsurers that have teams of meteorologists like me that are potentially putting a little bit of a what they call a cat load into those factors, for kind of a renewal season, based on what the longer term forecast might be for particular perils. La Nina, El Nino drive a lot of the world's different climate patterns. So I know kind of going into this year, typically we didn't see it this year, but Australia tends to be kind of wet and stormy in a La Nina, and that's kind of where we're in now. We didn't, so some shops were kind of taking into account. But we also know La Nina can cause more hurricanes and severe weather in the U.S. And in some regards, some meteorologists were advising the reinsurance industry of that. How much it really feeds into the overall rate, there's so many other factors that drive rate, in terms of cost of capital and things for them, that it's probably pretty small at this point, particularly given the amount of uncertainty.
We are right at just shy of 2 o'clock. So, really want to thank you, Andy, for participating in today's webinar and also the podcast that's going to be released. Really appreciate it and really look forward to seeing what the year brings.
Yeah, well, thanks again for the opportunity, and have a great afternoon or morning wherever you're from.
All right. Well, thank you very much.